in the series on the lazy mathematician. Don't be fooled. It takes a lot of hard work to become a lazy mathematician.
Today, we will take a look at some options for performing a multi-step algebraic equation. When I look at this equation, I see several things going on. I see addition, subtraction, and multiplication. I see possible distribution and an equal sign. Your goal is to solve this equation in the most efficient manner. In other words, untangle this expression so that you can isolate the variable x and find the value that will make the equation true. Students who are ready for this instruction already are familiar with the algebraic properties of equality and how to use them properly to keep the value of an expression equal on one side to the value on the other. Think of keeping your equations in balance. Students will also have practiced with 1- and 2-step solutions like those pictured here. Our goal of solving a multi-step equation requires us to accomplish 3 learning objectives which go along with Bloom's higher orders of thinking. I told you it would be hard work. Before you jump into the solving part, you must take a good look at the problem before you and analyze it, identifying your options. Next, you must make a plan, basically making a decision for just how you will start, making sure you considered all your options and choosing the easiest path. It's a good idea while learning new math skills to try several different approaches and hold the work up side by side to evaluate which method worked out best and why. Not every problem of the same type or in the same chapter will follow the same patterns. You must learn to analyze the numbers given to you and make individual decisions for each problem. I will try to demonstrate what I mean in the following slides. Feel free to use the pause button anytime you need to take notes or to stop and think. Now let's go back to the problem presented at the beginning of this presentation. Many students see the parentheses and they immediately want to simplify by doing the distribution. And they get 3x plus 6 minus 12 equals 36. Next, they might add the 6 and the negative 12, so they get 3x minus 6 equals 36. Then they add 6 to each side of the equation and come up with 3x. Let's see, what is 6 and 36? I think it's 42. Finally, they need to divide by 3 on each side and get x equals 14. You might have to do some long division here unless you have your 42 divided by 3 memorized. So that would require you to say, let's see, 42 divided by 3. Let's see, it goes in one time, 3, subtract, and I've got a 4. Yeah, x equals 14. All right, so that's one way to attack that problem. Let's take a look at this same problem and try it a third way. I think this time the first step I want to do is start by getting rid of this minus 12 business. So I'm going to add 12 to both sides of my equation. 3 times x plus 2. Adding 12 here. What's 36 and 12? I don't remember 36 and 12. Oh, it's 48. Okay, let's try to just divide by 3 on both sides. How did that sound? So x plus 2 equals, I don't know, 48 divided by 3 off the top of my head, so I'm going to go 3 into 4 goes one time. That's 3, subtract 1, 18. 3 goes into 18 16 times. That's 16. All right, the last step I have to do is to subtract 2 on both sides, and x equals 14. Well, outside of the fact that I had to do some additional scratch work off to the side, this one seems so far to have the least number of steps. You want to make sure you have the least number of steps because the fewer steps you make, the fewer chances you have to mess up. So let's go ahead and take a look at that again. On the first method, we had 1, 2, 3, 4, 5 steps. Last method, we only had 1, 2, 3 steps. So things are definitely getting a little easier for us. Oh, hi, it's me again. And I just wanted to say, we just looked at some different methods that resulted in us having to do different varying numbers of steps. It's important to keep our number of steps as short as possible. But also another thing you want to keep in mind is to keep your numbers as small as possible. Let's take a look at that. Division is a good choice for making numbers smaller. I'm taking a close look in analysis mode at this equation, and I'm noticing three terms. I have 3 times x plus 2 for one term. The next term is minus 12. And on the other side of the equation, I have 36. All three of these terms are evenly divisible by 3. So that's kind of nice and neat. Let's go ahead and do that, otherwise known as dividing by 3 on both sides of the equation. Divide the first term by 3. I have the x plus 2. Negative 12 divided by 3 is negative 4, and 36 divided by 3 is 12. Can go on with our simplifying. Let's combine these like terms here, and I get x minus 2 equals 12. That was simple enough. And then we have x minus 2. I need to add 2 to both sides. So I have x equals 14. And look at that. We are back at the answer. And I didn't have to do any scratch work off to the side because the numbers were so small. I was able to do all of the work in my head. Always a big time saver. I want to show you a problem where maybe dividing is not the right first step. 3x plus 5 minus 7 is equal to 6. I'm going to start this time by, I'm looking at this 3 over here, and I'm looking at this 6, and I'm thinking let's divide by 3 on both sides. X plus 5 minus 7 equals 2. Do you see what I did wrong? I made a mistake. I forgot I did not divide everything by 3. You have to divide everything by 3, not just the ones that work out pretty convenient, because we are now out of balance and we got big troubles here, so we're going to have to start over. I just did that for demonstration. I see so many students make that exact same mistake. I just had to let you have a look at it. Alright, so I'm going to divide by 3 across the board. I have x plus 5 minus 7 over 3 equals 2. This 5, I'm going to turn them into 5 over 1 and multiply them by 3 over 3. So this is x plus 15 over 3 minus 7 over 3 is equal to 2. And go ahead and add those up. X plus 8 over 3 equals 2. Alright, we got a lot of work to do. We have to subtract 8 over 3 on both sides, so it's 2 minus 8 over 3. Now again, I have to combine that fraction with this whole number. It's 2 over 3. Well, hallelujah, that is the same correct answer that we got last time. Only this time we had 1, 2, 3, 4, 5, 6 different steps. I don't know about you, but I'm thinking, looking to me like division across the board, although it made the numbers smaller, didn't really make my work any easier, probably made it a little bit worse.
What is the moral of this story? Why did I show you so many problems, so many ways to do the same problem? The moral is don't skip the analyze step. You might not want to use the same procedure on every equation you get. You must stop, look, analyze, consider your options, think ahead, choose the best method for each individual equation.